Hello students, a very pleasant and warm good morning greetings to you all. I hope you all are doing good, right? So, in the last class we discussed about atoms and modern atomic theory, isn't it? So from that atoms and modern atomic theory, now I am going to ask some question to you. Okay, are you ready to say the answer? Yes, good. So see the first question. The idea of atom was first proposed by whom? So who gave an idea of atom? Are you remember? Yes, Greek philosophers. When they gave the idea of atom? In the 5th century. Okay, in the 5th century, Greek philosophers give an idea of atom. Then second question. Atomic theory was proposed by whom? Who gave the atomic theory? John Dalton. This is very important question. Okay, John Dalton gave atomic theory. Okay. Then third question. Atom of one element can be transmuted into atom of other element is called as dash. Atom of one element is transmuted into atom of other element is called is dash. Artificial transmutation, right? Artificial transmutation. Then modern atomic theory, that is a 4-mark question. 7 points are there. Lot of points we discussed, right? Isotopes, isobars, artificial transmutations. Lot of points we discussed about that, right? So today we are going to study atom and atomic mass. Okay, atom and atomic mass. In the last class itself we studied about atom, right? So atom is the smallest particle, you all know. So today mainly we are going to discuss about this atomic mass. Based on this atomic mass, today we are going to learn two topics, that is relative atomic mass and average atomic mass. Okay, what are they? Relative atomic mass and average atomic mass. So see this picture. Some solids, liquids, gases are given, right? So anything in the world that has mass and occupying space. Okay, anything in the world, may be solid or liquid or gases, anything in the world that has mass. Mass means that has weight. So anything in the world that has mass and occupying space is called as matter, right? So see, each particles, solids or liquids, gases, anything, they have the unit of atom. You all know, right? It is made with atom. So atom is the building block of matters. Okay, atom is the building block of matters. So due to the presence of atom, now atom has some weight, right? So due to the presence of atom, matter has mass. Okay, due to the presence of atom, matter has mass. Okay, according to modern atomic theory, are you remember what point we studied in modern atomic theory? First point, atom is no longer indivisible, right? Discovery of electrons, protons and neutrons. So see here, this is a simple atom, okay, carbon atom. So according to modern atomic theory, atom has some subatomic particles, okay, that is electrons, protons and neutrons. Okay, atom has subatomic particles, that is electrons, protons and neutrons. Okay, so you all know each atom has small nucleus, right, inside. So here in this carbon atom has nucleus. This nucleus contains, what are the things present inside the nucleus? Can you say? Yes, protons and neutrons. Okay, inside the nucleus protons and neutrons will be present. Okay, but this electrons is revolving around the nucleus. Okay, electrons are revolving around the nucleus. These are the subatomic particles. So according to modern atomic theory, atom has subatomic particle, that is electrons, protons and neutron. This protons and neutron has considerable mass. Okay, it has particular weight. Okay, protons and neutron has considerable mass, but this electron has no mass, they have no weight. Okay, electron has no mass. So see, so mass of an atom means it was mainly contributed by protons and neutrons. Okay, so atom contains mass means it must be contains protons and neutrons. Okay, so here we are going to learn the point mass number. Okay, in the last class itself I told you what is atomic number, what is mass number. So again we are going to study about the mass number. Mass number means number of protons plus number of neutrons. So you have to write the point, the sum of number of protons and number of neutron is called its mass number. Okay, so now you count the number of protons and neutron in this carbon atom. So how many protons are there? 1, 2, 3, 4, 5, 6. Okay, 6 protons. So like that neutrons, count it, 1, 2, 3, 4, 5, 6 neutrons. Okay, so here in this carbon atom contains 6 protons and 6 neutrons. Totally how many numbers? 12 numbers, right? So the mass number for carbon is 12. Have you understood? Then atomic number. How we can predict the atomic number? Number of protons or number of electrons. You know number of proton here 6. Count the number of electron 2, 3, 4, 5, 6. So number of electron also 6. So atomic number 6. Okay. So see the definition, mass number. The sum of the number of protons and neutrons of an atom is called its mass number. Okay, can you study? So you have one note, right? So after completing this video, you have to note this question. Okay, you have to note this mass number in your note. Okay, and see individual atom. So individual atoms are very small. You all know atoms are very, very small. So atoms are very, very small. So we cannot predict the mass. Mass easily. Okay, we cannot easily find out that weight. Okay. So if you are taking macroscopic materials, macroscopic material means some of the big things, little big things, rice or mangoes, apples, any other things. So you know we will measure that things in gram or kilogram, right? So these atoms are very, very small. So that is measured in the unit AMU. Okay, it is measured in AMU. AMU means atomic mass unit. Okay, this is a one more question. So please note it. The mass of an atom is measured in atomic mass unit. Okay, so question is the mass of an atom is measured in dash atomic mass unit. Okay, AMU. So what is atomic mass unit? So what is atomic mass unit? Atomic mass unit is 1/12 of the mass of a carbon 12 atom. That means atomic mass unit is the 1 part of carbon 12 atom. Okay, it is a 1 part of carbon 12 atom. Carbon 12 means you know it is an atom, right? So carbon 12 is the mass number we found. But here it is an isotope. Okay, isotope of carbon. The last class we discussed about isotope, right? So what is isotope? It have same atomic number but different mass number. Okay, isotope is a say it has same atomic number but different mass number, that is a isotope. So here carbon 12, then carbon 13, carbon 14, so 3 types of isotopes are there, later we can discuss. Okay, so here what is atomic mass unit? It is 1/12 of the mass of carbon 12 atom. Okay, an isotope of carbon which contains 6 protons and 6 neutrons. Okay, and now we studied atomic mass unit. No, the mass of an atom is measured in atomic mass unit, but nowadays in the modern system chemists are not using this unit. Atomic, instead of this atomic mass unit, they are using the symbol U. Okay, instead of this atomic mass unit, they are using the symbol what? U. U means unified atomic mass. Okay, U means what? Unified atomic mass. Have you understood? So next we are going to study about the topic relative atomic mass. Okay, relative atomic mass. So before entering this topic, I could say one example. So if you are going to buy 1 kg rice, okay, if you are going to buy 1 kg rice, you will ask shopkeeper, give me 1 kg rice. Like that you will be asked. You should not, you never ask, give me 1 rice. Like that did you ask? No, right? You will be asked 1 kg rice, you will ask, right? So at that time shopkeeper what will do? He will use the weighing balance. This is old type of weighing balance. Okay, so in this weighing balance, shopkeeper will keep some standard value. In the one side they will use some standard weight. They have 1 kg or 5 kg, some standard weights are there, isn't it? So they will use in the one side, how he will measure. So in this one side they will keep weight, right? And another side, based on this weight, they will add little more, they will add, right? So like that here also, atomic mass, atom is a very very small, so we cannot be determine that mass accurately. Okay, so that chemists are using one element as a standard. Okay, they are using one element as a standard. So mass of an atom is relative to mass of another atom. That is called as relative atomic mass. To measure mass of one atom is relative to mass of another atom. Okay, in that example we saw shopkeeper used weight as a one side, right? So like that chemist use one standard atom at one side, and another side based on this weight they will add. Have you understood? So here carbon 12, now in this picture see carbon 12 is taken as a standard value, and this side based on this weight they are adding one by one. Okay, so up to 12 they are adding. Have you understood? So relative atomic mass means what? Mass of an atom is related to mass of another atom. Okay, mass of one atom is related to mass of another atom is called its relative atomic mass. Have you understood? So in the beginning, in the earliest periods, chemists used hydrogen as a standard atom. Okay, so instead of this carbon they used hydrogen. Okay, hydrogen as a standard atom, and this hydrogen have some isotopic character, hydrogen 1, hydrogen 2, hydrogen 3, like that some isotopic characters are there. That means they will be convert. Okay, they will be convert easily, they have no stable, so that they changed, instead of this hydrogen they changed it into oxygen atom. Okay, so now this oxygen atom also have no stable, it has also some isotopic character, oxygen 16, Okay, oxygen 17, some isotopic characters are there. So instead of this oxygen, again they changed oxygen to carbon. Okay, this carbon also have some isotope only. Okay, carbon 12, carbon 13, carbon 14 isotope. But this carbon 12 is very stable, naturally occurring isotope, carbon 12. So nowadays they are using standard as a carbon 12 atom. Have you understood? So relative atomic mass means to measure mass of one atom. Okay, to measure mass of one atom is relative to mass of another one atom. That is called as relative atomic mass. Have you understood? So we can see the definition. Before studying the definition, we can see this formula first. Okay, then it is easy to learn this definition. So this relative atomic mass is denoted as AR. Okay, mind it. Relative atomic mass is denoted as what? AR. So AR is equal to average mass of isotope of the element divided by 1/12 of the mass of one carbon 12 atom. Okay, what is the formula? Average mass of isotope of the element divided by 1/12 of the mass of one carbon 12 atom. Okay, so you remember this formula. From this formula, how we can write the definition? Listen here carefully. So relative atomic mass is defined as, okay, relative atomic mass is defined as, it is in the fraction form, right? So you have to use the word ratio. Okay, divided by, no, so you have to use the word ratio. So relative atomic mass is defined as the ratio between average mass of the isotope of the element. Here you should use the word 2, TO2, okay, isotope of the element, to 1/12 of the mass of carbon 12 atom. Have you understood? So can you study the definition? So first you should learn this formula, okay. So AR is equal to average mass of the isotope of the element divided by 1/12 of the mass of carbon 12 atom. So how you will write the definition? It is defined as the ratio between average mass of the isotope of the element divided by 1/12 of the mass of one carbon 12 atom, and it is denoted as AR. It is otherwise called as, this relative atomic mass is otherwise called as standard atomic weight. Okay, relative atomic mass is otherwise called as what? Standard atomic weight. Have you understood relative atomic mass? Yes. The next, some examples given. For hydrogen symbol H, values, relative atomic value 1. Carbon symbol C, relative atomic value 12. Okay, so relative atomic mass means that mass number only. Okay, so you don't confused about it. Nitrogen mass number 14, oxygen 16, sodium 23. By that way, by that relative atomic mass, they used to find out this mass number. Okay, magnesium 24, sulfur 32, symbols given. Okay, so H, C, nitrogen N, oxygen O, sodium Na, N capital letter, A small letter. Okay, mind it. Then magnesium Mg, here also M capital, G small. Then sulfur S. Okay, next, this relative atomic mass is only a ratio. Okay, here we studied it is in a ratio form, right? So relative atomic mass is only a ratio, so they have no unit. Okay, it is in the ratio form, no, so they have no unit. If the atomic mass of an element is expressed in grams, okay, if it was expressed in grams, then it is called as gram atomic mass. Okay, some gram atomic mass values given, they will ask in a 1 mark question. This is also a mass number only, remember it, but the unit is gram. Okay, so gram atomic mass of hydrogen is equal to 1 gram, gram atomic mass of carbon is equal to 12 gram, then gram atomic mass of nitrogen is equal to 14 gram, then oxygen 16 gram. Okay, So maybe they will ask in a 1 mark question. Please note it, these two tables. Okay. The next we are going to study about average atomic mass. Okay, average atomic mass. Before entering this topic, you should know about the word abundance. You should know the meaning about this word abundance. Okay, so abundance. So a small example I am saying, one man thought to buy a fruits. So he went to fruit stall to buy 7 mangoes and 12 apples. Okay. Now his carry bags contain 7 mangoes and 12 apples. Here, which one occupies more space? Apple or mangoes? Apple, right? Because more is there. 12 apples are there. Okay, number of apple is more. So apple occupies more space. So here what is abundance? So that space occupying, that occupying space, apple occupies more space, right? So that how much an object occupy a space is called as abundance. Okay, how much an object occupy a space is called as abundance, that is space occupying. Okay. So shall we see one example with an atom like that, mangoes and apples. So see this example, carbon 12, carbon 13, carbon 14. Okay, these are the isotopes. Okay, so in this carbon 12 isotope occupies 98.9% in our earth crust. Okay, it occupies 98.9% in earth. But this carbon 13 occupies 1.1 and carbon 14 occupies very less amount, less than 0.001%. So from here how they will, so abundance means occupying space. Carbon 12 occupies this much percentage, carbon 13 occupies this much percentage, carbon 14 occupies this much percentage. So from here how we can find out this average atomic mass. So average atomic mass of an element is the weighted average mass of its naturally occurring isotopes. So here chemists what they will do, if they want to calculate the average atomic mass for these 3 compounds, for carbon, okay, 3 are isotope, okay, compound means they will take these 3 values. Okay, these 3 values they will calculate and they find out the average value. Okay, so these are the naturally occurring isotope. So from this naturally occurring isotope they will take the average mass, that is the average atomic mass. Have you understood? So what is average atomic mass? Average atomic mass of an element is the weighted average mass of its naturally occurring isotopes. Okay, clear? So to calculate the average atomic mass, they have one formula, okay, that is mass of first isotope. So see this picture, this is the first isotope, this is the second isotope, this is the third isotope. So mass of first isotope, this is the mass value, right, 12. So mass of first isotope is 12 into percentage abundance of first isotope. Percentage abundance, so occupying space, how much space this carbon 12 is occupying. Okay, how much space? 98.9%. So 12 into 98.9%. Have you understood? So mass of the first isotope into percentage abundance of first isotope plus mass of second isotope. See here, see this picture, second isotope 13, mass value 13. So 13 into percentage abundance 1.1%. So percentage means we have to take on this value is divided by 100, right? So like that you have to find out. So in this picture you see 3 pictures are there. So first, second, third. If third means we have to add one more. This formula. Mass of third isotope into percentage abundance of third isotope. Okay. So this is the formula, mind it. Okay, so one example we can see. Let us consider an example which exists as a mixture of 50% of an isotope having the mass 9 AMU. That means one element has the mass number 9 AMU and the percentage abundance 50%. Okay, and 50% of another isotope having the mass of 10 AMU. What is the average atomic mass of an element? So see, you have to use this formula here. Okay, so first step you have to write this formula. Okay, I missed to write this formula here, but you should write this formula first here. Okay, so average atomic mass is equal to mass of first isotope. So mass of first isotope how much? 9. Okay, so 9 into percentage abundance of first isotope. Percentage how much? 50. So 50 divided by 100. Okay, percentage, so that only I mentioned here 100. Okay, into then second isotope how much? 10 AMU. So 10 into 50 divided by 100. Here 50 and 100 cancel, right? So you will be get 9 by 2. And here also 50 and 100 cancel. So you will be get 10 by 2. Okay. So 9 divided by 2 we will be get 4.5 plus 10 divided by 2 you will be get 5. So when you add this 2 you will be get 9.5 AMU. Have you understood this problem? You must note it in your note. Okay. Then some worksheet. You have to find out the answer from this video and write down. Okay. So the first question, the sum of number of protons and neutrons of an atom is called as dash. You know, sum of number of protons and number of neutrons. So at what answer will come, you should write it. Okay, in the next video I will say the answer. Okay, the mass of an atom is measured in what? Then relative atomic mass of an element is denoted as one symbol. I told you, no? Then fourth question, relative atomic mass is otherwise called as, they have the standard value, right? So they have one name, another one name. If the atomic mass of an element is expressed in grams, it is called as dash. If it was expressed in gram means it is called as dash. Then gram atomic mass of hydrogen is dash. Then define relative atomic mass. This is the 2-mark question. You have to note it in your book. Okay. So study well. I hope you all understood this lesson. If you have any doubt, please ask in this comment box. Okay. So in the last class, you have to work out it. In the next video, I will say the answer. We will continue in the next class. Okay. Thank you.